So we classify alcohols as primary, secondary, and tertiary in much the same way that we classified carbon atoms. A primary alcohol is where we have the hydroxyl-bearing carbon being bonded to only one other carbon. So we're looking at the carbon that has the hydroxyl group on it. Now methanol doesn't fit in here. It would be less than primary. We often lump methanol in with the primary alcohols because it reacts in many of the same ways. But this is an example of a primary alcohol. So here's the carbon that the hydroxyl group is attached to, and we look and we see how many other carbons are attached to that carbon. Well, here there's one. So that's primary. This is a secondary alcohol where we have two carbons. So R can stand for methyl or ethyl or propyl or dodecyl or any of those guys. And here a tertiary alcohol, and we've got three different carbons attached to the carbon with the hydroxyl group. So it's a little bit different than when we were talking, you can't have a quaternary alcohol because the hydroxyl group is one of them. But you're looking at the carbon that the hydroxyl group is attached to. We need to understand this because the chemical reactions that alcohols undergo often depend on what class they are in. Some reactions only occur on primary alcohols or secondary, etc. When we have an increasing number of R groups on that hydroxyl-bearing carbon, it's going to decrease the extent of hydrogen bonding. And this is called steric hindrance. So here we have a primary alcohol, and this has a long chain. And when we start to branch this chain, this one's secondary and this one's tertiary, same number of carbons, now things start to get kind of bunched up, and this has more of a ball shape than this one does. And so that affects the intermolecular forces and causes differences in their boiling points. So primary alcohols are going to have stronger intermolecular forces for their size. So this one has a boiling point of 118. When we start to branch this, make this a secondary, the boiling point goes down. When we branch it into a tertiary, the boiling point goes down even farther. And that's called steric hindrance, and that's these R groups are getting in the way. So here's an exercise. Classify each of the following alcohols as primary, secondary, or tertiary. What is A? We're looking at the carbon that the hydroxyl group is attached to. How many carbons are attached to it? Secondary. There are two carbon atoms attached to it, so it's secondary. How about this one? We're looking at, you find the hydroxyl group, and what is the hydroxyl group attached to? It's attached to this carbon. What else is attached to that carbon? How many carbons? Only one, right? So that one's primary. You guys awake? How about this one? Primary, secondary, or tertiary? Secondary. There's the hydroxyl group, so this is the carbon we're interested in. It's got 2 carbons on it, so that's secondary. Come on. Secondary. How about this one? Secondary. So this carbon is attached to that one and to this one. It's also secondary. You would have thought that they would have put a tertiary in there.